Greetings, peeps. Today our topic is metric prefixes. Metric prefixes are just modifiers that come before a number that change the magnitude of that number based on powers of 10. So, for example, I got two columns here, 12 prefixes in total. On the left side, we have modifiers, these prefixes, that increase the magnitude or the amount of a number. For example, deca will increase a number by power of 10 to the first. 10 to the first power, which is 10. So it would be 10 times greater. Kilo, for example, is 10 to the third. It would be 1,000 times greater. Giga, 10 to the ninth, 1,000,000 times greater. And then we have tera at 10 to the 12th, or a modifier that indicates something is 1,000,000,000,000 times greater. This column over here is the same kind of concept, except instead of increasing the magnitude, it decreases the magnitude by powers of 10. So for example, deci is 10 to the negative first. So that value would become 1/10 of what it was before. Milli is 10 to the negative third, 1,000th. Nano, 10 to the negative ninth. That would be 1,000,000,000th. And pico, 10 to the negative 12th, or 1,000,000,000,000th. So these prefixes also have letters that represent them. DA for deca, capital M for mega, little m for milli, little n for nano, big T for tera, and over here, micro is an interesting one because this is actually a Greek letter. It looks like kind of a weird M, but it's actually the Greek letter mu, mu, mew, mew, like a little kitten, M-E-W. That's kind of like the mu over here, like that. So you might have heard some of these before. They're pretty common. A kilometer is unit distance, a little less than a mile that you guys would be familiar with. There's milligrams, measure mass, for example. Mega millions, if you play the lottery, but you know, that's not. Who knows? Who knows, right? But, for example, I can show you a device known as a pico projector. And a pico projector, because it's really, really small, it's a very tiny projector inside there. One day I'll show it to you. The little pico projector is pretty cool. And I was going to show you also my Nano, or iPod Nano, but I can't find it. It's so small. I've lost it. I can't find it. So that's how small it is. I just can't even find it. I was going to show it, but that's all right. You know what they look like. What is the distance of a nanometer? Well, nanometer is 10 to the negative 9th meters. So in numerical form, it looks like this. So we've got a decimal place followed by 8 zeros and then our number. Or we have a swing to the left of 9 decimal places. 1, 2, 3, 4, 5, 6, 7, 8, 9. And so this number here is succinctly represented as 10 to the negative 9. So that's really cool. An example of something at the size of a nanometer would be a strand of DNA. For tera, I chose, because it's a really big number. I just wanted to show you what that looked like. It's a 1 followed by 12 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I used the terabyte. A byte is a unit of information. It represents a character of information. So, for example, Twitter uses approximately 140 bytes per tweet, and a terabyte can be found in typical hard drives like this. And so a terabyte might store about as much as, say, 200,000 MP4, MP3 songs. That's a lot. That's something you may not listen to in a lifetime. So it can store maybe about 140 DVD quality movies, Blu-rays. And so it's quite a bit of information now available for $100 to $200. So it's rather incredible. All right. Thank you. Morad out.